Okay, so we are back for the third section of Chapter 3, and what we're going to do is we're going to write quadratic equations. Three learning targets, they all are writing quadratic equations, one in vertex form, one in intercept form, uh, and then lastly that you can use quadratics to solve real-life problems, and these are all going to kind of go hand in hand together. It's just you're going to have to specifically write in vertex and intercept form, and then you're going to use those to actually solve some problems. Okay, so let's go ahead and just kind of look at the first example, and let's just dive into it. Okay, so we're going to write an equation using a point and a vertex. Okay, so we have a random point, and then as well as also have the vertex. So the graph shows the parabolic path of a performer who's being shot out of a cannon. So this person's here in our cannon. They're being shot out. In the y-axis here, you can see the height in feet. Okay, and x here is the horizontal distance traveled. Okay, so this is their height, and this is how far they've traveled from along the ground from the cannon itself. Okay, we want to write an equation of the parabola, and then the performer lands in a net 90 feet from the cannon. What's the height of that net? Okay, so we have a little extra part that we're going to need to add in together. So the big thing that you're going to need to know here is that we're writing specifically the information we're given gives me the vertex and then a random point. Okay, so those are the two things that are going to help you get started, is identifying on my graph, in words, however they're presenting that information to you. You have a vertex and a point. Okay, and that information is going to be the enough information to get you started. Okay, so we want to start by identifying what are the major pieces of information I have. I have a vertex and a point. Okay, whenever you have the vertex, you're going to want to start in vertex form. Okay, so vertex form is the form y is equal to a times x minus h squared plus k. Okay, and then just to recall from lesson 1 in this chapter, that's when we learned about vertex form. So if you need more information on it, I'm going to give you a quick run through here right now. But if you just need more on it, just go and rewatch that video. Okay, otherwise here, remember A tells me whether my parabola opens up or down. It also tells me the width, like is it going to be a narrow parabola or a wider parabola. H shifts the vertex from 0, 0. It shifts the vertex from 0, 0, right and left. And, okay, so right and left only. When H is negative, it's going to move it left. And when H is positive, it's going to move it right. And then K will move the vertex vertically up and down. If this is negative, it's going to move it down. If it's positive, it's going to move it up. Okay, so what we have to do is we have to find A, H, and K. Once we have all of those, we're going to be able to kind of assemble the parts together into this form and then inevitably solve or have an equation. Okay, so let's just go ahead and start. What you really want to start with is, since we know we have the vertex, that's the easiest part. If you recall from lesson 3.1, we know that the vertex in vertex form, okay, is the ordered pair h comma k. Okay, so you need to remember that the vertex is h comma k. So when we look at our specific problem, where's our vertex? Our vertex appears to be the ordered pair 50, 35. So I know that my vertex is 50, comma 35. Okay. Okay. So this tells me a bunch of information, right? It tells me what h is equal to. Okay, so think to yourself, what is my h value? It's 50. And what's my k value? 35. Okay, and this makes sense, right? Here's 0, 0. My h value is positive 50, so that means it's been moved to the right 50 units. K value is positive, that means it's been lifted up 35, all relative to 0, 0. And that's very consistent with what we have. So, right there's a bunch of bits of information to go ahead and plug into the equation. Okay, so now I know that my equation is y is equal to a times x minus 50 squared plus 35. So all I did was replace h and k. And so these particular problems are really nice if you know those forms. Again, as I discussed in 3.1, I spent a lot of time on, if you understand what a, h, and k do, it makes a whole lot of things easier. You can have an idea what the graph looks like. You can be given a graph and have a lot better idea of what the equation is going to look like. And so those are very valuable. So again, if you don't have those down, you might want to go back to 3.1 and rework some stuff. Okay, now the only thing that's missing is a. Now, just in my own head, I can already kind of come to the conclusion this parabola opens downward as opposed to opening upward. Downward would be more of like the frowny face. Upward would be more of a smiley face. So it's opening downward. So we know a is going to be negative. So that's pretty important as it is. But how do we actually find that value, whether it's 15, 3, a half, whatever it may be? We need to know what the a numeric value is. Okay, this is why you also need a point. You can't just have a vertex, and although it's going to give you very important information, right, it depends how it's opening up. And this other pair here is 0, 15. So your other point, let's see where my blue pen went, right here. So we know my other point, okay, because to have enough information, you need the vertex plus some other point, because that other point is going to be, the equation for a parabola will be specific to the vertex and one random point on the curve. And then there's only one equation that will satisfy those two conditions. So the minimum amount of information you need is you need the vertex and at least a point. So what is that other point? That other point is going to be x comma y, right? It's just got a random x value and it's got a random y value. So for us, what is that? It looks like it happens to be 0, 15. So I'm going to do this one in blue so we can kind of see that the blue will be replacing the variables, where h and k are replacing values into our equation. Okay, so my other point is 0, 15. So what I can now do is I can replace all of these values, x and y, with 0 and 15. So that means 15, okay, 15 is going to be equal to a times, well, I do know what x is now. I know my x value for this particular ordered pair is 0, so I can replace x with 0. Minus 50 squared plus 35. Okay, so now you may not have recognized it yet, but as I look at this, I now have an equation here, and even though there's an exponent, there's only one variable. And there's no exponent on this variable. That means right now we have enough information to actually go through and solve for a. So if you think about it, that's quite clever because, you know, I'm starting with this information. Well, I know those are just going to go right in. Well, that other point here, even though I had 3 unknowns, it whittles it down to 1 unknown, and then we have enough information to solve for it. So we can just go ahead and do that. And I'm going to do that up here. Okay, so I know that 15 is equal to a times, well, 0 minus 50 is negative 50 squared, and then plus 35. Okay, and so then I've done my parentheses, so now I want to do my exponents. Okay, so here I have negative 50 squared. So I've mentioned this once before this chapter already, the difference between this. If you just type negative 50 squared, nope, that's the wrong button, negative 50 squared, okay, you are going to get negative 2,500. This number is actually wrong, dead wrong, because This here has, take the opposite of what 50 squared is. That's kind of how I would read this. 50 squared is 2,500, and the opposite of 2,500 is negative 2,500. So technically what it's doing, it's going negative 1 times 50 times 50. That's what this is going to do. As opposed to here, negative 50 quantity squared. Well, what does that mean? That means take negative 50 and multiply it by negative 50. And this is what we're looking for here. So I'm going to hit enter, and it's a positive 2,500. Okay, so you really have to watch out. Like, we even have it written with parentheses, so it's a little tougher to screw up, although not impossible. So you just look out for that. Okay, so here I'm going to have 15 is now equal to 2,500 A plus 35. Minus 35 from each side. Okay, I believe that's negative 20. And all right, okay. And then here I have 2,500 A. Okay, and then if I want to get the A by itself, I'm going to divide by 2,500. Okay, now A is going to be equal to, and then here we could get a decimal. Like, I would be totally fine with this if you gave me negative 0.008, meaning this is a very wide parabola compared to the parent function. The other option is you can go ahead, hit math. Okay, the math button is just right here. And then here, the very first one says frac. What that will do is it will reduce the fraction negative 20 over 2,500 for us. And that's negative 1 over 125. That's what I'm going to go with. Okay, you could simplify this by hand, but I'm assuming you've already mastered that at some point, so you don't really need to. Okay, so what is my final equation that represents the flight of this human cannonball? It is y is equal to a, which is negative 1 over 125, which, again, is a good sign because this was negative, right? And we knew it was going to be negative right off the get-go because it opens down, times the quantity of x minus 50 squared plus 35. Okay. So there is one more part, and we're kind of running out of space. So I'm just going to grab a separate sheet of paper here. Yeah, this will do. Okay, and so then it says that the performer lands in a net 90 feet from the cannon. So here, 90 feet from the cannon, right here. It's actually this dot right here. This person's landing in a net. There's a net here. Okay, and we want to know, like, how high off of the ground is that? So we want to think about what kind of information do I have, knowing that it's 90 feet from the cannon away. So if both the cannon is on the ground, 90 feet horizontally from that lies our net. I want to know how high in the air is that net held. Well, so we know that the net is 90 feet. That means that my x value in this situation is 90. So x is 90. I want to find the y value that coordinates with it. Okay, so let's go ahead and do that. We do need our equation. So let's go ahead and use our equation. So this is now y is equal to negative 1 over 125 times, well, we know x is 90, so I'm going to replace x with 90. Okay, you have a couple options. You could just straight up basically put this whole thing in your calculator and hit enter. As long as you're putting it in there correctly, that's fine. I think for the sake of this one, we can just go ahead and we can just do this one by hand really quick. It won't take too long. Okay, so this is, okay, 90 minus 50 is 40. Okay, 40 squared is 1,600. Okay, and then I have to go negative 1 over 125 times 1,600. So here, negative 1 over 125 times 1600, okay, is negative 12.8. Plus 35, and that's 22.2. Okay, so let's take a look here. Here's 20. Does our answer of 22.2 feet above the ground seem reasonable? Based on knowing that this line is 20, this one's 30, so then this one would be 25. Okay, so we knew it was going to be somewhere between 20 and 25 feet. But we know that exactly it's 22.2 feet. And that seems totally reasonable based on that assumption. So I'm just going to put here 22.2 feet. Okay. Okay, so that's kind of how you do these problems. Before I ask you to do the next one, because I don't think the next one has you elaborate upon anything, I really would like you to think about something like, what do all the different bits of information tell you? For example, if I wanted to know, like, what is the height when the feet is 20, like, you would just plug x into my equation. Well, what if I wanted to know where is the highest point? What are you looking for if you're looking for the point where it's at its absolute highest? Well, this one was given to us because it's a vertex. But that's what you would be looking for, is the vertex, because we know that the vertex, based on previous sections, is the highest or lowest point. So that's what you would be looking for. What if I wanted to know, like, pretend there was no net, when would he hit the ground, right? So then we'd be looking when y is 0, and we have different ways of solving those type of things. Okay, so those will pop up occasionally. You're just going to need to think about, like, the questions aren't always going to ask the same thing. They're not always going to ask, what is y when x is 50? Or what is y when x is 90? It might be asking something a little bit different. You're going to have to try to interpret what that means and, like, what special point would that be on our parabola. Okay, so what I want you to do right now is I would like you to move down to A. It's actually using no like problem or setup. This one's just straight up asking, write the equation of a parabola that passes through the point -1, 2 and has a vertex for -9. Okay, so I'm going to ask that you do that right now, and you can check my work with me here in a moment. Okay, so I'm assuming that you have already went ahead and paused the video and tried this on your own, and here's my work. Okay, I identified I had a point and a vertex, so I'm going to start in vertex form. Okay, my vertex is 4, -9, so h is 4, k is -9. So I went and replaced h and k in the equation with these values. My other point is -1, 2, so I know x is equal to -1 and then y is 2. So I went and replaced y with 2 and x with -1. Then I solved. -1 minus 4 is -5. -5 squared is positive 25. So now I have 2 is equal to 25a minus 9. So I add 9 to each side to get 11 here. So 11 is equal to 25a, so I divide by 25 to get a is 11 over 25. Okay, then I have y is equal to 11 over 25 times x minus 4 squared minus 9. Okay, no extra question asked on this one, so this is kind of all I was looking for. Again, vertex moved is consistent with what we have here. One thing I did know my a value was going to be positive here, because if I look at my vertex, I have a -9 in the y value, and this y value is above it, meaning that it has to open up. It doesn't really have any other option. Just something to think about as you're working through these a bit. Okay. So, this one here, we're going to be using a point. Okay, we're going to be given a point, and both of the x-intercepts. Okay, the x-intercepts are going to be an important part. Okay, and so we need to think, what's the other form that we could use? We actually have three forms. We've already used vertex form, and shocker, you use vertex form when you're given the vertex. This one, I'm given the x-intercepts, so to your surprise, we will be using the intercept form. So intercept form is y is equal to a times x minus p times x minus q. Okay, that is your generic form where p and q are your two different x-intercepts. And a is the same functioning a as all the other ones, where it tells you whether it opens up or down. Okay, let's go ahead and do this one. Okay, so a meteorologist creates a parabola to predict the temperatures tomorrow, where x is the number of hours after midnight. Okay, and y is the temperature in degrees Celsius. Okay, we're going to write a function f, okay, so we can mess with that here at the end, that models the temperature over time. And then we would like to know, what is the coldest temperature? This is a great question because it talks about exactly what I was talking about at the end of one, where it doesn't always ask, like, find y when x is 7. It's asking what's the coldest temperature, and we have to think about that in this problem. So, what do we want to start with? Well, in this one, we want to start with the x-intercepts. Okay, the x-intercepts, it looks like, are at 4, as well as, where else is an x-intercept? 24. Okay, so as I look at this, it is at 4, because this is where it crosses the x-axis. It does have a nice little point for us, but it crosses the x-axis here at 4 and here at 24 as well. So those are our x-intercepts. Next, all I have to do is, I just have to plug those in. Here, P and Q, totally interchangeable. You can have PB4 or PB24 here. Doesn't matter. Totally interchangeable. I'm just going to go, kind of as it's written. Y is equal to A times X minus 4. And then times X minus 24. Okay, and the thing that's nice about these problems is you just have to have the forms figured out. Once you have those forms figured out, actually getting the equation is going to be the same process, right? It's just the starting point is different. This one, I have the x-intercepts to start with. I'm going to write my equation in intercept form. The previous problem, I had the vertex to start with. I'm going to start with vertex form. Those are just the easiest ways to find them. Okay, so then from here, I have that one other point, 0, 9.6. Okay, and again, it doesn't have to be when x is 0. I could pick any point on the line that's not an x-intercept and plug it in. So here, then we have the other point. Okay, what's that other point for us? Well, it looks like it is 0, 9.6. Okay, so what does this mean? This means that I have an x value equal to 0 that is on my curve when my y value is equal to 9.6. So this is actually quite handy because, again, for the same reasons, we can just go ahead and plug them in. Furthermore, x is 0, so that's going to really reduce the amount of work I'm going to have to do. Okay, so let's go ahead and plug this in. So I know that 9.6 is going to be equal to A times 0 minus 4 times 0 minus 24. Okay, there's multiple x's in our equation, so we just have to go ahead and plug both of them in for that same x value. Okay, so let's go ahead and start solving. We'll do this by hand because shouldn't take too long. So here I have 9.6 is equal to A times, 0 minus 4 is negative 4, right? Simplify the inside of the parentheses first, and then 0 times or 0 minus 24 is negative 24. Okay, so here I have 9.6 is equal to a times negative 4 times negative 24. So I do have this multiplication I can move together. So we're going to take negative 24 times negative 4 here to get 96. So I have 9.6 is equal to a times 96. Okay, I wrote the a first on accident, so this kind of looks weird, but I think normally what you would write this as 9.6 is equal to 96a. That's just how you would see it written. Okay, so then here I have 9.6 is equal to 96a. I need to divide by 96 here. Okay. Hopefully you can see that they're kind of the same number. This decimal has just been moved one place, so that it means that this is going to be 1/10, which is equal to a. Again, you can go ahead and take 9.6 and divide it by 96, and then go ahead and hit math and then fraction for that first one to get 1/10. Okay, lastly, let's just put all the parts together. So my final equation is y is equal to 1/10 times x minus 4 times x minus 24. Okay, so that is the function, okay? And it wants the function written as the function f. So instead of y, we should say f of x is equal to 1/10 times x minus 4 times x minus 24. Okay, function named f, where x is our time. Okay, so then there's this other question. What's the coldest temperature? Well, visually, I think we can see that the coldest temperature is at this very bottom peak, right? Because this is our temperature. The lower we go, the colder the temperature. So it's going to be right about here, and it looks like it's probably about negative 10. But we don't know that for sure. It could easily be like negative 0.999 or 0.90, something along those lines. Something really close to that line that we can't really tell. So I want an exact number. So let's think about what important point always will have my highest or my lowest point. Okay, the vertex. So hopefully you're all saying to yourself, the vertex is going to tell me what that point is. Well, how do I find the vertex when I'm in this form, or it's not just given to me in the previous problem? Well, the vertex always lies on the axis of symmetry. Symmetry. So we know that this whole figure is symmetrical, even though they don't have the other part of the graph shooting up. It's symmetrical. So I know that my x value of my vertex will be exactly in between 4 and 24. So what number is exactly between 4 and 24? It's 14. So what I need to do is I need to find, for the coldest temp, I need to find f of 14. Okay, so let's go ahead and do that. F of 14 is equal to 1/10 times 14 minus 4 times 14 minus 24. So that means f of 14, the function when x is 14, is 1/10 of 10 times, I think that's negative 10. I'm just double checking. It is. Okay. Okay, and then so then f of 14 is equal to, let's go ahead, just throw that in our calculator. 1/10 times 10 times negative 10. Hopefully you're identifying that this is just going to be negative 10, which is kind of what we thought it was going to be. But that's just good. It's kind of confirming our original thoughts as true. Okay, so our coldest temperature is 10 degrees Celsius. Okay, what does the x of 14 mean? This means 14 hours after midnight, we are expecting to have the coldest temperature of negative 10 degrees Celsius. So 14 hours after midnight, that'd be like 2 o'clock in the afternoon is what we would be expecting. Just a weird time to have the coldest temperature of the day. But we didn't create the model. We're just doing math to confirm all this other stuff. Okay, so what we just did is we just used this quadratic equation, using a model to estimate something, right? So this is all just an estimation. This doesn't mean that at 2 o'clock tomorrow, the lowest temperature is definitively going to be negative 10. It's just saying that we can, based on some numbers and data and this person's estimation, we believe it's going to be about negative 10. This is not the only way to use estimations. There is also that concept of rate of change, which we've seen before. So let's just go ahead and take a look at the rate of change between points and just kind of see how they compare. Okay, so what is the average rate of change over the interval in which the temperature is increasing and decreasing? Okay, so let's just talk about increasing, decreasing. This is important. Increasing is when is the graph going up from left to right, and when is the graph going down from left to right. So we know that the graph is decreasing from here all the way to this vertex, which we know to be 14, negative 10 based on the previous problem. So I want to know what the rate of change is on that. So I'm going to do this one here in red here. So if I just draw a straight line between the 2 points, this is the estimated rate of change, this red line. Now, is this red line accurately depicting the actual temperatures given the time? No. If you can see that this red line here is actually overestimating everything. Okay, so is a straight line necessarily going to be the best estimation tool for this? No. But that doesn't mean that it doesn't have its values. You know, maybe if we had tons of curves and the graph was way zoomed out, this would be a little better estimation. Okay, but for this particular one, it's not going to be great. This is why we have different types of functions besides straight lines. Okay, because we know that it's going to decrease faster here, okay, then it is going to be decreasing from here, right? Like if we just created a straight line here, like if I wanted the average rate of change between this point and this point, okay, like that straight line is going to actually be relatively accurate. It's not a straight line here, it's a curve. So the error is going to be just off as opposed to picking this point and this point. So with curves, you can pick straight lines to find rates of change. That will model a curve but not be very accurate depending on how small you look at. Okay, so let's just go ahead and find the rate of change when it's decreasing. Okay, so when it's decreasing. Okay, when it's decreasing, it's starting at 0, 9.6, and it stops decreasing at 14, negative 10. Okay, so if you recall, this is just literally the slope formula, and hopefully you all have this memorized. M is equal to y2 minus y1 over top of x2 minus x1. Okay, so let's go ahead and do this. Y2 is negative 10 minus y1 is 9.6. Here, x2 is 14 minus 0. Okay, so then this is going to be 10 minus 9.6 is negative 19.6 over 14, which is negative 19.6 divided by 14 is negative 1.4. Okay. So let's just talk about what this means. This negative 1.4 means that on average, now I'm saying those words very clearly, that this means just on average, really indicating that this is an estimation. Okay, it's losing about 1.4 degrees every hour after the every hour after midnight. Okay, on average 1.4 degrees every hour 1.4 degrees, every hour 1.4 on average. But is that what really is happening? No. Again, the same reason, right? This line here, it's decreasing from this hour here, from midnight to 3 a.m. It is decreasing faster in that rate than it is from 3 a.m. to 6 a.m. Okay, the further we get from the vertex, the faster it's going to increase or decrease. As opposed to the closer, the slower it's going to decrease. It's kind of like that mountaintop. It kind of just flattens out a little bit after a while. Okay, so this means that on average, it loses 1.4 degrees Celsius every hour. Even though that is not actually, it doesn't actually lose 1.4 degrees every hour, because that's how straight lines work. Okay, again, that's how straight lines work. It loses a certain amount every single time, like your slope. This line doesn't have, or this curve doesn't have a slope. You can use a line to estimate little chunks, but as you can see here, this is not necessarily the greatest estimation tool. Okay, what I want you all to do is I want you all to identify when it's increasing, the little interval when it's increasing, and then also find the slope and check in with me when you're done. Okay, so we can see that the graph starts to increase at our vertex, and then the only information we have here is this point here. So we're looking at this rate of change right here. Okay, again, we can see this straight line here. Even though it's a little better estimation of this curve than this one here, right? Because we've picked a little bit smaller chunk to work with. It's still not great, right? It's not really all that close to the line. It's not the greatest estimation tool. But in some regards, it's the best we have, okay? So it starts increasing at 4, -10, and stops at 24, 0. So 0 minus -10 is +10. 24 minus 14 is 10. 10 over 10 is 1. So on average, and this is something I should have included here, is from 2 p.m. to midnight. So from here, I should have said on average from midnight to 2 p.m., okay, from midnight, the temp increases 1 degree Celsius every hour. Okay, so hopefully some of you are thinking like, well, I thought all of these figures are symmetrical, so they should be increasing and decreasing at the same rate from the vertex. Well, you are right. They are symmetrical, but if you looked, we picked a 10-hour time frame here, and here we took a 14-hour time frame. So the rates of change on average that it's going isn't going to be the same. But again, that's because it's curved, right? It's going to increase slower from here to here as it is from here to there. So you just have to look out for that. Okay, this is just a little way that we can use straight lines to estimate parts of curves, but never the whole thing, and it's going to have some error to it. Okay, so what I want you to do right now, okay, is pause the video, and I want you to try letter B, which is write the equation of a parabola that passes through the point 2, 5 and has the x-intercepts -2, 4. That's going to be just like right up here, what we did at the top. Okay, so pause the video and check in with me here in a moment when you are done. Okay, so as I'm looking at this, okay, I know my x-intercepts are -2, 4, and my y-intercept and my other point is 2, 5. So I went ahead and I replaced P and Q with -2 and 4. Okay, so if we look at this though, the basic equation calls for subtraction. It says x minus P. So when I replace P with a negative number, it's minus a negative. Well, what does minus a negative result in eventually? Plus. Like, right, this is eventually going to just turn into x plus 2. Okay, just so you know. Okay, and then x is 2 and y is 5. So 5 is equal to a times 2 plus 2, this 2 coming from my x value 2, times 2 minus 4, which this 2 is coming from this 2 as well. Okay, so then 2 plus 2 is 4, 2 minus 2 is -2. 4 times -8 is, or 4 times -2 is -8. And then here I have 5 is equal to -8 times a. I divide by -8 to get -5/8 here. And that's my a value. Okay, so it looks like we're moving on well. So, what we are going to do now is we are going to use the calculator to go ahead and get a model for this. Okay, so here we have NASA can create a weightless environment by flying a plane in parabolic paths. The table shows the height h of the plane t seconds after the starting path. Okay, after 20 seconds, the passengers will begin to experience a weightless environment. Write and evaluate a function to approximate the height at which this occurs. Okay, so here we just have a bunch of numbers, okay, times and heights, okay, that coordinate together. Okay, if we were to plot them, they go ahead and give a curve. So let's go ahead and get our calculators out. Calculator's going to do most of the work on this problem here, okay? Okay, so we've already known how to write some equations by hand. What if we're just given a whole bunch of ordered pairs and we want to know, like, what curve could best represent this? Now, this doesn't mean necessarily that our curve, so let's say we have some ordered pairs like this, okay? Okay, if I put them on a graph, okay, they kind of follow like an arc, right? Like a parabola. Okay, we can use quadratic equations to model this data without it going through all of the points, to use it as an estimation tool. And this is used in all sorts of business aspects, in science, and often we just call them regressions, like what's the best fitting line. Okay, so what we're going to do is actually see that happen on the calculator. I should have explained that in the front end. Okay, so what you would need to do is you need to go ahead and go into Stat, okay, Stat button right here, and then the very first one says Edit. Okay, so it looks like I actually have some stuff in list 1 and nothing in list 2, but I do have some things in list 1. The DEL is just delete, and I did not mean to delete that. So here I gotta reset my calculator quick. Okay, catalog, and clear all this. Okay, sorry folks. I seem to have deleted that list entirely, which is just fantastic, and I do need list 1. So I'm going to spend a little bit of time here. Pretty sure there's a button that just lets me full reset my calculator. Oh, yeah, I'm here. Okay. Okay, let's say something like that happens to you. Very well could just happen to me. Okay, if you ever need to reset your calculator completely, just to like wipe fresh, start over, you hit the second button, and then you hit the plus sign. MEM is for memory. You hit that, and then it's you can do all sorts of stuff, but if you just go down to 7 and hit reset, and then all RAMs, and then reset, okay, we haven't programmed anything in there, but now you can see like it's just kind of refreshed our whole calculator together, just in case that happens, which it could. So okay, so let's start over. Okay, so what you want to do is you want to hit Stat, okay, and then Edit. Okay, if you have things in your list, so let's say I have a couple items like 2 and 3 in here, and I just wanted to delete the 2 and 3, highlight the 2, hit delete, highlight the 3, hit delete. If you go up here and you hit delete, you will delete the list. L1 for list 1, L2 for list 2, and then you might have to reset your calculator if you do that. Okay, so in list 1, let's go ahead and put in all of the times. So I'm going to have 10, 15, 20, 25, 30, 35, 40. Okay, and then with that, I want to match the heights with the corresponding t value for time. So 26,900, 29,025, 30,600, 31,625, 32,100, 32025, 31400. Okay. So now I have all of I have my list plugged in there. Okay, and if you have to pause the video to put this stuff in your own calculator at any time, that's no problem. Okay, the next thing what we're going to do is I want to actually visually see these ordered pairs listed out on the coordinate plane. So what I'm going to do is I'm going to hit second and then y equals to see the stat plot, okay? And what you want to do is we can just go into the first one and we want to turn it on, okay? And here it can give you all sorts of different graphs. We are definitely looking for this one here is just a dot graph, just all the isolated dots we have, where I want my x values to be list 1 and my y values to be list 2, and then this is how the mark's going to look. So when you hit graph, you would think that it would pop up, but in this situation it did not. Why did it not? Is because we're not looking in the right area. We're looking from -10 to +10 and from -10 to +10 in the y values. Okay, look at here. Our x values go from 10 to 40. Okay, so let's go and change that. So let's go to the window. You hit window. What do I want my x values to look at? Well, I know I have 10 to 40. So let's just go a little before at 0 and a little after 50. Okay. Okay, x scale is like how many tick, like what's it going to go by on the tick marks? Everyone is fine. What about the y values here? My y values range from a lot, right? They go from 2,600 to 32,000, or 26,000 to 32,000. So this is a pretty big window we need to look at. So for me, I think I'm going to start at like 20,000. And then I need to get at least a 32, so I'll just go 35,000. Okay, so this is kind of, I really hope you paid attention during this because I get a lot of questions like, what should my window range be for X's and for Y's? Well, you have to look at your data and come to the conclusion yourself. Like, I knew mine was from 10 to 40, so it seems reasonable to include 0 to 50. Here, 26,000 to 32,000, like 20 to 35. It's going to be different for everybody, but you need to be able to see all your data points. Okay, so there's our dots. And it seems reasonable for us to have a curve that could go through most, if not all of these. Okay, a parabola, as a matter of fact, that would represent this situation well. So let's go ahead and do that. Okay, so what I want to do is I'm going to hit stat, and I'm going to go to calculate. Okay, so I hit stat, I tab to the right to calculate, and if I go down to number 5, it says quadratic, which stands for quadratic regression, which is exactly what we're doing. Essentially saying, find me the equation of a curve that fits these dots the best they can. Okay, so let's do this. Quadratic, hit enter. Okay, and it's going to put it in standard form for us. So it's -11 is A value, B is 700, and C is 21,000. So let's go ahead and just write that down. I know that A is -11, B is 700, and C is 21,000. Okay, meaning that my equation is going to be h of t, because height as a product of time. Okay, got a glare out of nowhere. Not sure where that came from. Okay, so I have h of t is equal to -11 t squared plus 700t plus 21,000. Okay, so this is the equation to my function representing all of these ordered pairs that we had. Okay, so what do we have to do next? It says after 20.8 seconds, okay, approximate the height at which it occurs. Okay, so we know so what we can do here is now we have this graph. Let's actually get the line in there so that we can see. Okay, so let's go ahead and do that. I want to give a little bit of space here. Perfect. Okay, so what we can do is we're going to hit y equals. Now, I'm going to graph the whole equation here. The only thing is our variable is t. The calculator only recognizes x's, which is unfortunate. So we're going to hit -11 Okay, and then x is right here. Okay, it has xt, theta, and n. We're going to hit that one. That it will just by default pop up x squared plus 700 x plus 21,000. And then after that, we can just hit graph. Okay, so now we have our curve going through. It looks like it actually goes through all of our points. So for me, I would say that this fits my data well. It's a good, accurate representation of it. Okay, and so what I want to know is I want to know the height when the time is 20.8 seconds. So we can do this with a whole bunch of different ways. Okay, when you hit second and then trace. Okay, so you're going to hit the second button and then trace. It's going to give you a whole lot of different options. Okay, and you might want to write some of this down, I think. Okay, one of the pages does have a little bit of an outline on here, but okay. The number one value is going to give you a y value when you have the x. So if I know what x is going to equal, I can plug it in and we'll find the y value. This is the zeros, or it's going to find where does it cross the x-axis. Minimum, it's going to find the vertex when it's a minimum point. Maximum, this is going to find the vertex when the vertex is a maximum. And then intersect is going to find where you find two graphs will cross each other. Okay, so given this situation, which ones of these do we have? When I want to know what's the height after 20.8 seconds. Hopefully, after maybe watching this once again, you're saying to yourself, well, I want to find the y value when I have the x value. So that's this one. So what's my x value? It's 20.8. And the height is 30,800.96 feet. Okay, so let's go ahead and this. So this means that we will feel a weightless environment. Okay, we're going to feel a weightless environment after 20.8 seconds at 30,800.96 feet. So this actually is a great representation of quite literally the flight of the plane. And right about here is when they're going to feel a weightless environment. Okay, after 20.8 seconds at about 30,800 feet. Okay, so I definitely talked a lot during this trying to get you to understand what the concept, but this actually should go quite a bit faster. Yeah, so why don't you all try example C, okay, and then you can check it with me here when you're done with that right now. Okay, so I am going to go ahead and this glare is driving me bonkers. Okay. I'm just going to do this one right here in front of you because just to get used to the calculator buttons, and a lot of students have had issues with that in the past. But you'll get used to it, okay? So what I want to do now is I'm going to go into my y equals. I'm going to clear that out. Okay, I don't need to mess with the window yet, but I do need to go in and change my lists. Okay, so I'm in Edit, and I'm going to delete all these entries, just kind of mashing delete. All right, we're doing the same thing here. Okay, and then we can get started here in a second. The table shows the estimated profits Y in dollars for a concert when the charge is X dollars per ticket. Okay, write and evaluate the function to determine what the charge per ticket should be, maximize the profits. Okay, so this is a great question. Okay, so we know that our ticket prices are 2, 5, 8, 11, 14, and 17. And the profits we get when the ticket prices are 2 or 2,600. Profit is $6,500 when they're $5, $86 when they're $8, $89 when it's $11, $74. Okay, we'll talk a little bit more about this. Let's just get the math part done, and then we'll discuss more. Okay, so stat, calc, quadratic regression. So A is negative 100, B is 2,000. C is negative 1,000. Okay, so my function is y is equal to negative 100 x squared plus 2,000 x minus 1,000. Okay, so then let's go ahead and let's set up our window by looking at our x and y values so we know where to look at. So it looks like our x values go from 2 to 17. So what would be a reasonable window of x values to look at, right? Starting at 2, need to get to at least 17. I think it seems reasonable to go to 0 to 20, maybe 25, you know, something a little past. Okay, what about the y values? Looks like my y values range from as low as 2,600 to as high as 8,900. So it might make sense to maybe go from 2,000 to 10,000 or 2,000 to 9,000. I'm going to go 10,000 just in case we need to look up a little bit higher than that. I always like to have a little extra if I can. Okay. And okay, so there's my dots. Let's see how, which that definitely looks like a parabola. Let's see how my graph looks when I do that. Negative 100 x squared plus 2,000 x minus 1,000. And again, the X button is right below the button that reads mode. It has the link right next to it. It's right here, diagonal from the second button. Okay, and then hit graph to look. Okay, really looks like it fits the data points as well. Okay, so what's the question being asked? Okay, so we already wrote an equation, but we want to evaluate the function to determine what the charge per ticket should be to maximize profits. We're trying to maximize profits here. Maximize profits, that means we want the ticket price that's going to give me most profits, the highest amount of profits possible. That is going to be the vertex when the vertex is a maximum. So I'm going to hit here, second, trace. So second, then trace. And I need to think about which one of these 5 am I interested in. And we're only interested in the first 5 in this class. So I'm looking to maximize profits. I'm looking for the vertex when it is a maximum, which is number 4. So when I'm looking at the maximum minimum function here, what you need to do is, you can see it says left bound, question mark. What that means is just like make sure you're to the left of what you know is the highest point. So I'm going to say right here, I guess. Then it says right bound, meaning tab to the right until you know you are to the right of that highest point definitively. Okay. And then it says guess, because it doesn't have your answer yet. You have to hit enter one more time to guess. And then it's going to give it here. There will be times where your numbers will be different, but they'll be like decimals way out here because it is just an estimation tool. So it looks like for me when my X value is 10, my Y value is 9,000. So here I know I have a vertex at 10, 9,000. So what does this mean? This means to maximize profits, you need to charge $10 per ticket. Okay, and let's talk about why would prices and profit margin have a representation like this? I mean, wouldn't you just think the more you charge, the more money you're going to make, right? I mean, if I charge everybody $50 and I have 100 people coming in, doesn't matter. I'm going to get $50 from each of them. Why wouldn't I do that? Well, let's think about why they wouldn't do that. Here early on the curve, okay, early on my curve, let's say like right here. Like, why would my profits be less here when my X value is 2? Why would I not be making as much money? Well, hopefully you're thinking to yourself, well, you're not going to be making as much money because you're not charging very much money. Like, you're only charging them $2 a piece, but like you have all of these costs that go into, I'm assuming this is a movie theater, which I used to work at one when I was a kid. You have all these costs going in, and you have to run the projector and buy popcorn seed and get cups for pop and straws and have the temperature. You have all these costs. So if you're only charging $2, like, yeah, you might be making a profit, but your profits aren't going to be very much. What about if I go right here, right? This looks like profits are going to be about, this is $5, right? Why would my $5 tickets be more, right? Well, because it's $5. You're getting $3 more for every single person, but you're going to be making a good profit off of that. Why, once I get to, like, let's say this one looks like it's probably about $14. How come when I get $14, it's not that much more when I get to 8? So there's a breaking point, right? The breaking point is literally our vertex, but there's a breaking point where the tickets cost so much money that people aren't going to come in. So, for example, yeah, you might get a lot of people coming in, but your profit margins between your costs and the amount of money you're spending aren't going to be very high. Where $14, you're going to cut a great profit on everybody that comes in the door because, you know, $14 a ticket is quite a bit. But that price point disincentivizes people to come into the doors in the first place because they go, God, do I really want to see the, I don't know, whatever movie, do I really want to see some movie for $14 when I can just wait for it to come out on Netflix or whatever? You know, that's, so there's a certain point where ticket costs are so high that less people start coming, and you're gonna break even, and you're not gonna have as much profits, as opposed to that breaking point, which is our vertex, which is our maximum, where that's gonna say this is the point where people are comfortable coming in, and we're gonna cut the most profits on it. And that's why profits and ticket prices may form a curve such as this. Okay. All right. I will actually skip the last page because it's the same thing. If by demand we need me to go back over another regression problem, I will. I don't think it's super necessary now that I have a video and that you can go back and watch these different things. Maybe I'll start the next session with this because I'm already over an hour, which is longer. Okay, last thing before you go. Folks, I have created on the last page of this is a quadratic regression cheat sheet. What it is it shows a screenshot of what your calculator, whether it's an 84 or 83 plus, is going to look like, right? This is just the buttons here, okay? And then it does give you some important information. It gives you literally a walkthrough of buttons that you need to press with screenshots of what your screen will look like, okay, and the buttons that you need to press. Okay, below here in the corner, it also is going to give you the exact buttons you need to press to find a value on the curve or to find the min-max of a curve, which is finding the vertex. Okay, otherwise, that is it for this lesson. It was a little bit longer, a little bit more talking, but I don't think the math was all that rigorous. So move on to the homework, and I will see you next time in 3.4.